My name is Seth Shonkoff. I'm the Executive Director of PSE Healthy Energy. PSE is an energy science and policy research institute focused on the public health, climate, and environmental dimensions of energy production and use. I am going to now turn it over to Dom DiGiulio after I introduce him. Dom is a senior scientist at PSE Healthy Energy, and he's also has a research affiliation at the University of Colorado at Boulder. Dr. DiGiulio was a regulator at US EPA for 6 years and then worked for 31 years in the Office of Research and Development at the United States Environmental Protection Agency. And after that time, he headed to Stanford University and then came to PSE to work full time. And he's been with us for about 5 years. So just as a reminder, we're going to save Q&A for the end. We're planning on having about 15 or so minutes at the end to discuss any questions that you have. If you have questions, we highly encourage you to write them down in the chat and share them, and I'll be moderating that at the end. So at this point, I'm going to hand it over to Dr. DiGiulio and take it away. Thank you.
Okay, thank you, Seth. The focus of this presentation is in Tulare Basin in the southern San Joaquin Valley. I think a lot of people get it somewhat confused. So the San Joaquin Valley to the north is the San Joaquin Basin, and the Tulare Basin is the southern part of the San Joaquin Valley. Approximately 99% of the unlined produced water ponds lie in the Tulare Basin. So almost all the unlined produced water ponds or impoundments in California lie within the Tulare Basin. The concern here is groundwater as a resource, in particular with concern about climate change. With climate change and sustained droughts, there really is a heightened need to protect groundwater resources. I was just reading last night that this past year in California was the driest year since 1924. So there are definitely concerns about maintaining the sustainability of groundwater resources. So this disposal process of disposing oil and gas wastewater, or better known as produced water, goes back to the early 1900s. So this disposal practice dates back over 100 years. Impact to groundwater from this type of disposal practice is well documented. There are papers that go back into the 1960s that highlight the concerns about disposing oil and gas wastewater into unlined pits. See, these disposal ponds are fairly large. The Legionnaire 100 meters is about a football field in size. So, a fair amount of these facilities are very large. So let's first go into the classification of unlined produced water ponds. The first classification is active produced water ponds. So these are ponds that are currently still in operation. There's inactive produced water ponds where they currently do not receive produced water, but they can sometime in the future. And then there's historic ponds or closed ponds. And there's a fairly large number of closed ponds in the Tulare Basin. So in terms of treatment of produced water or oil and gas wastewater, there's really not very much treatment that goes into this waste product prior to being discharged into these unlined produced water ponds. Something like 95% of the water is not really treated beyond just removing oil. I think it's necessary to put this disposal practice into context. Both in previous years and in current years, the vast majority of produced water is disposed of by subsurface injection in the Class 2 injection wells. But historically, disposal of unlined produced water into these impoundments that are not lined has been fairly substantial. But as of 2014, there was a significant reduction in this practice. So if you just follow these years here, it's fairly substantial. And then in 2014, it really tapers off. So in 2017, it was approximately 1.4% of the produced water that was generated in the state of California. But that's still a substantial amount of fluid when you consider something like 3 billion barrels per year of produced water disposal. I think it's important to look at this as a cumulative process as well. And there's, with this particular slide, it's the cumulative volumes of disposal as a function of time. So that this summarizes all the surface means of disposal. So it's evaporation, percolation ponds. It's disposal by line sumps, surface water bodies, surface water and sewer. So over the past, at least since 1977 up to 2017, over 16 billion barrels of produced water have been disposed into these unlined produced water ponds. So there's definitely a concern about these legacy issues. An enormous volume of produced water has been disposed into these unlined pits. And so I think that's, that's an issue of concern moving forward. Back in May of 2014, the Central Valley Regional Water Quality Control Board began an effort to better regulate disposal into these unlined produced water ponds. So back in 2014, most of these facilities did not have a waste discharge permit, and the ones that were permitted were more than 20 years old. Since that time, the Central Valley Regional Water Quality Control Board has done a much better job in terms of issuing permits. But back in 2014, the board really began a fairly sustained effort to better regulate these unlined produced water facilities. I just want to point out the groundwater resources that are in the Tulare Basin. To the east is a Kern River formation. To the west is a Tulare formation. And then on top of that is alluvium. So if you get a chance to actually read the paper, there's a fairly significant amount of detail about that. It's really necessary to understand these formations, to get a better idea of the groundwater resources within the southern part of the San Joaquin Valley. But I'm not going to spend a whole lot of time with that here. So this is I kind of wanted to go into the definition of protected groundwater that's relevant to disposal of produced water into these unlined produced water facilities. There's a whole series of policies in the state of California that go back to 1968. That there's an anti-degradation policy that dates back in 1968. Back in 2002, there's a Porter-Cologne Water Policy Act. There's a Tulare Lake Basin Water Quality Control Plan. There's a 1988 Sources of Drinking Water Policy. And there's general orders that the Central Valley Water Board had issued back in 2017. So in terms of determining how you protect groundwater in the Tulare Basin with this disposal practice, it gets fairly complicated. But going through these investigations and looking at how basically the Water Quality Control Board is regulating or defining what's protected groundwater, it seems to boil down to the state's sources of drinking water policy in terms of protecting groundwater to a level of 3,000 part per million total dissolved solids. The problem here is that this is not consistent with oil and gas development with the rest of the state. With the underground injection control program pursuant to the State Drinking Water Act, groundwater is protected to a standard of 10,000 part per million TDS. And looking at protection of groundwater resources with well stimulation, it's also protected to a level of 10,000 part per million. So in terms of defining what to protect here, if you're going to protect groundwater, you really have to have a definition of what the standard is. And the fundamental problem here is the standard is not consistent with the rest of the state. So pursuant to SB4, the State Water Resource Control Board had to convene an expert panel to determine what was a standard or a definition of protected groundwater during well stimulation or hydraulic fracturing. And then there was a public meeting that was convened back in May of 2019, which we presented at. And the conclusion that the State Water Resources Control Board came up with at the time was that it's technically feasible and it's economically feasible to protect groundwater at a standard of 10,000 part per million TDS. So that's, again, that's what's done with the underground injection control program. That's what's done with well stimulation, but that's not the standard that's being used to protect groundwater resources with this disposal practice. The technical basis of protecting groundwater at that standard, really, there's no difference with the technical basis with SB4 and with well stimulation. So it's the same economic and technical considerations are the same in terms of protecting groundwater to the same level with these unlined produced water ponds. So quickly, what the objectives of this investigation were to get a better idea, to develop a comprehensive evaluation of what was going on here with these unlined produced water ponds in the Tulare Basin. So we wanted to look at the number and the status and location of produced water ponds. We wanted to get a better idea of the composition of produced water that was discharged into these unlined produced water ponds. We wanted to get a better idea of the levels of TDS in groundwater that underlie these unlined produced water ponds, to look at the vulnerability of groundwater resources with these ponds. And then we wanted to look at groundwater investigations that were conducted at these unlined produced water pond facilities to look at impact, at documented impact to groundwater resources. So quickly, the methods, we basically looked at the produced water ponds list on the State Water Resources list that's available. We looked at WellStar with CalGEM, and then we mostly spent time on GeoTracker, which is a fantastic system that's set up by the State Water Resources Control Board to track all facilities in the state of California that have a potential impact on groundwater resources. So that also had a lot of data on characterization of produced water, which is a fairly tedious process of going through PDFs to download virtually all of this data. But we went through every produced water ponds facility. So this investigation was fairly comprehensive. To get an idea of TDS levels in groundwater in the vicinity of these produced water ponds, we looked at the State Water Resources Control Board's Gamma program. And a more recent one in the Tulare Basin that was back in 2018. So I kind of want to go through this pretty quickly. So the results were, we developed a fairly comprehensive database on where these produced water ponds are located throughout the Tulare Basin. So that database is part of the paper. We looked at facilities that were not documented in terms of being on any particular list. And so these are, scarred areas that could potentially be produced water pond facilities that are not currently documented. And what we came up with was a total of 1,850 unlined produced water pond facilities within the Tulare Basin. And one of the difficulties that we had was there was no state agency or list that really documented all the unlined produced water ponds. So if you looked at the State Water Resource Control Board list, there was compounds or facilities that were unique to that list. The same thing with WellStar and GeoTracker. So it's really not a one database that could be located within the state of California that could track all of these facilities. So on the right-hand side here shows where the facilities are located. There's active facilities in red. There's unlined inactive facilities in yellow and closed facilities in gray. So within the Tulare Basin, the far left-hand corner there, it totals about 1,850 of these facilities. And you see unlined facilities in different shades of blue are a fairly minor component of these produced water pond facilities. And then in many cases, we couldn't really tell whether they were unlined or lined. So some were inactive, active, closed. And then with the unidentified facilities, there are the scarred areas that we really couldn't tell if they were active facilities or closed facilities or not. So there's a fairly large number of these unlined produced water pond facilities within the Tulare Basin. With the composition of the produced water that went into these unlined facilities, we went through that, and there's different shades here. One problem is that there's bias associated with interpretation of data based on the number of detections versus the number of chemical analyses. So most of the major ions like sodium and chloride, potassium, the rate of detection was fairly high. So they're in different shades of blue from 99 to 100%. Then a lighter blue in terms of chemical analysis, when you detected it, it varies from 90 to 98%. With the organic compounds, most of the organic compounds detected in produced water were BTEX compounds. So BTEX is benzene, toluene, ethylbenzene, and xylenes. We also found naphthalene. So they were detected a little bit more than half of the time that they're actually analyzed for. And some of these levels, we included the state maximum contaminant levels. Like for the state of California, the maximum contaminant level is 1 microgram per liter, which is 1 part per billion. So you can see that the concentrations of that benzene, which is known human carcinogen, in some cases was very high, and so there's definitely a concern there of some of the organic compounds are very mobile in the subsurface environment. The Tulare Lake Basin standards for discharge of produced water into these unlined produced water ponds for specific inductants or electrical conductivity is 1,000 microsiemens per centimeter. You can see that the salinity of the vast majority of water that gets discharged into these unlined produced water ponds is extremely high. So most levels are well above that. And then for the effluent standards for chloride is 200 milligram per liter. So if you look at chloride here, it's very much above that. And then for boron, the Tulare Basin effluent limit is 1 milligram per liter or 1 part per million. So for the most part, the water being discharged was well above that level as well. So with this study, we basically went through and we summarized all this data for each facility that's in the Tulare Basin. So that's in supporting information. And we also looked at BTEX compounds. So we looked at the rate of detection. So, all this data is very specific, not only the parts of the Tulare Basin, but each facility. Again, this is in supporting information. So in terms of the TDS levels in groundwater in the Tulare Basin, this graph pretty much charts out what we found. So the small blue crosses are public and domestic water wells that have specific or discrete latitude and longitude. And then the parts in blue here are various parts of the subbasin within the Tulare Basin. So the Tulare Basin has a whole series of subbasins, groundwater subbasins. And then because there's so many produced water ponds within the Kern County Subbasin, we broke that up into individual parts of the Kern County Subbasin. So these different shades here are levels of total dissolved solids in groundwater within the Tulare Basin. So you can see this scale on the right-hand side here. So as you move from the east to west, the water gets, the groundwater concentrations of TDS get higher throughout the Tulare Basin. And then in terms of plotting these unlined produced water pond facilities, there's these bubbles here. So again, the red bubbles are the active facilities. The yellow is the inactive facilities, and the gray are closed facilities. So this big star here is Bakersfield. So you can see that the vast majority of these unlined produced water ponds are in the western portion of the Tulare Basin, where the groundwater, levels are somewhat higher than the eastern part. So with the eastern part of the Tulare Basin, they're usually less than 500 part per million. So that's generally considered very high quality groundwater. So there's a whole series of unlined produced water ponds that are located in what's considered fairly, above fairly high quality groundwater. Within the western part of the basin, the TDS levels get somewhat higher. So I guess, one of the criticisms that will be, I guess, stated about the study was that there's a general viewpoint that in the western portion of the Tulare Basin that the groundwater is so-called poor quality groundwater. But when you actually go through where there's documented studies of groundwater contamination, most of these facilities lie within lie east of these oil and gas fields, where the groundwater is really not poor. The levels of total dissolved solids close to these facilities was between 3,000 and 4,000 part per million. So it's somewhat higher levels of TDS compared to the eastern part, but fairly close to what the Water Quality Control Board is regulating in terms of 3,000 part per million TDS. So it's really not poor quality groundwater here. The quality of the groundwater improves as you move east, but certainly where these unlined produced water ponds are located, the levels of TDS are really not that high. So I wanted to go through this fairly quickly. We broke this investigation into different subbasins, and we looked at the levels of TDS within each subbasin. In the central eastern part of the Kern County Subbasin, which is right here, there is the Racetrack Hill facility, which is this large yellow dot here. Levels of TDS are generally below 1,000 part per million, so it's fairly high quality water. We looked at the median levels of TDS and electrical conductivity within each subbasin here, and so this table with each area presents that. So just going into one investigation here quickly is the Racetrack Hill facility, which is in the central eastern part. And so with each of these, there weren't very many facilities that had discrete groundwater investigations. And we wanted to look at facilities that did have specific investigations to document impact of groundwater resources. So this is part of the eastern part of the Tulare Basin. And if you look at the levels of electrical conductivity here and total dissolved solids at the facility itself, where there was disposal, it's so the groundwater monitoring wells have a TDS level greater than 7,300 part per million. And then as you go into background levels, it's less than 500, it's 380. The direction of groundwater flow in the Kern River Formation is to the northeast. And so with this particular facility, we tried to map out the extent of impact with each of these unlined produced water pond facilities that actually had groundwater data. With this one, it extends out about 0.5 kilometers. And then if you move to the western Kern County subbasin, where there's a lot more facilities, you can see that the levels of TDS that were disposed in these ponds is much higher, up to 42,000 part per million. Benzene concentrations in produced water that were disposed in these ponds up to 5,700 parts per billion. So fairly high levels of benzene and chloride and TDS. So I wanted to point out a couple of facilities here that we looked at. This is one area where these facilities are closed. So there's a whole series just east of the Belridge South Field, where there's a whole series of closed facilities here. So if you look at levels of TDS that are in groundwater that are at the facility boundary, it's fairly high level, 36,000 part per million. If you look hydraulically down gradient around 1,900 part per million TDS. So again, the groundwater in the western part is not necessarily bad quality groundwater. You can see here that the TDS level is 1900 part per million. And there's a dramatic decrease in concentration with electrical conductivity, TDS chloride, as you move to the northeast here. So if you look at these monitoring wells, the extent of impact, at least to the last monitoring well that was showing clear signs of impact, was 4 kilometers away from these closed facilities. The unimpacted water wells are a distance of 6 kilometers. So the distance of impact here varies between 4 and 6 kilometers. So I think the point here is that with these fairly large facilities, the magnitude of impact, the distance of impact from these facilities can be fairly extensive. We're not sure whether it extends, it's somewhere between 4 and 6 kilometers here. So that's a fairly extensive distance. I think one important aspect to point out here is that active remediation, which constitutes pump and treat, can be extremely expensive. Like at the South Ponds facility here in the Lost Hills facility, it was estimated that active remediation with pump and treat would cost $1.5 billion. So the method of treatment that was decided upon was natural attenuation, which is pretty much allowing contaminants to disperse and organic compounds to biodegrade over a period of time. So the point here is that once you've contaminated groundwater, it's really too expensive to remediate. You essentially just have to let this stuff disperse over a period of time. The problem is that these groundwater plumes are moving. So with this particular area, it's obviously a whole series of facilities forming a very large groundwater plume. We're moving towards agricultural, parts of the basin. There's below this area is the McKittrick 1 and 1-3 facilities. So with the previous impact, it was alluvium. With this particular facility, it's a lower Tulare formation, which is a regional aquifer in that particular area. So again, this is a concern. There's a whole series of facilities here. With the McKittrick 1-1 and 1-3 facility, the extent goes out between 2 and 3 kilometers. And these facilities are currently not active. There's no groundwater monitoring here. So that's another problem, is that with McKittrick 1 and 1-3, there's groundwater monitoring wells. We could have some idea of the tracking of the plumes. With these inactive facilities, which would dispose a comparable amount of produced water, there's no current groundwater monitoring wells. So I think one more major concern here is that there's a whole lot of facilities out here where fairly large volumes of produced water have been disposed. That currently no groundwater monitoring is occurring. So there definitely needs to be more investigation conducted. This portion. Very high levels of specific inductance and total dissolved solids. The levels in some cases are extremely high because of evaporation of produced water. There's a couple facilities here that I want to point out. One is the Maricopa West facility. Again, there is groundwater contamination there, and it's moving between 1.2 kilometers and 2.1 kilometers away from this facility. And you can really tell what's going on by looking at the levels of electrical conductivity, TDS chloride. You can see there's a really rapid drop off here as you move away from the facility. So near the facilities themselves, it's very high levels. Here in this particular case, the background levels of TDS are 3,300 part per million. So just really slightly above what's being protected. And I just want to end this by going over the implications of this particular investigation. So what we found here is that this disposal process has been occurring since the early 1900s and continues to this day. Produced water often has very high levels of electrical conductivity, TDS, chloride, boron, and VOCs, such as benzene, which are mobile in groundwater. We found that the disposal of produced water into these unlined produced water ponds often overlies groundwater having present and future use. And groundwater monitoring is actually very sparse, but where monitoring has in fact occurred, impact of groundwater resources has been observed and proven too expensive to actively remediate. Again, back in 2015, pursuant to SB4, a panel was convened, an expert panel to look at these unlined produced water ponds. And one of the things that came out of this this effort was this report by the California Council on Science and Technology and Lawrence Berkeley National Lab. And they concluded, based on their investigations, that these unlined produced water ponds do pose a risk to groundwater resources in California, and that the produced water discharge of these unlined ponds should contain non-hazardous constituents, or this disposal process should be phased out in the future. They recommend further that investigation should be conducted to determine if historical disposal activities have impacted groundwater resources. And so that at least in part has continued, but again, as pointed out in this presentation, there needs to be a lot more work done. So our results, this comprehensive assessment really bolstered their recommendations. We've gone into a lot more detail with this investigation. This investigation here was much more comprehensive than what was conducted in the past, but we essentially came up with very similar recommendations. And it really gets back to this definition of produced water, or this definition of protected groundwater not being consistent with the underground injection control program in the state of California, and with the definition of produced water with well stimulation. We believe if the definition of protected groundwater for disposal in these unlined produced water ponds was at 10,000 milligram per liter as opposed to 3,000 milligram per liter, it would limit this disposal practice. It would not eliminate this disposal practice, but it would certainly limit this disposal practice to a significant degree. That, however, would not address the legacy issues. Again, going back to being over 16 billion barrels of produced water was disposed, and there's still a large number of large closed facilities where there's significant groundwater impact. So this recommendation would address active facilities, not the closed facilities. And so a lot more work needs to be done with addressing groundwater contamination at those closed facilities. And I don't know how much time I took, but I think we have plenty of time for questions. Thank you.